I'm going to finish up about the drug related with the cardiovascular system, and this one is just light version than the cardiovascular one. Yeah. It's not intended that the previous one. Yeah. And the learning objectives for this class, you have to define or explain about the hematopoietic, hematinic, and anything related with the drug, and hemostatic, or the drug with related anti-hemostatic. And you will need to describe the disposition for each agent, but don't need to memorize all things. The one have the unique characteristic. And of course, because we are going to be veterinarian in future, you need to know clinical indication for each agents, yeah, and describe the mode of action and the adverse effect. And before we go there, we're going to talk about a little bit about definition. Okay, well, we have two parts together. I thought like I said something wrong. Okay, we have two parts together. The first hour, we're going to talk about hematopoietic agents, and that agent related to help the product of the red blood cell. And the second part, the second hour today, we're going to talk the agent for the bleeding disorder. And the first one, hematopoietic agents, that means any agents can relate with it to produce a red blood cell, and can be two parts together. First, hematinics. Hematinic is a nutrient or the supplement that help red blood cell to mature and to produce for the system. And the second one is a hematopoietic growth factor. Most of them is a hormone and can be a growth factor. But some textbooks, they call all two parts together as a hematinics. Because sometimes you find like a hematopoietic growth factor as a hematinic. I want to let you know that some people, they call that in the one word. Yeah. A little bit background. For the hematopoietic agents, we use to treat anemia. Anemia, as we know, is a condition of the red blood cell is lower than the normal range. And that can cause the body cannot use the oxygen. The oxygen supply is not enough for the body system. Because the red blood cell is the key thing to carry the oxygen to the tissue, and the tissue need to the metabolism for their cells. But sometimes for the anemia, you have to know what is the real cause that causes the anemia. Can be two things, like the produce is not enough, or have the destruct or the destroy for the red blood cell too much. For the destroyed red blood cell can be blood loss. The acute blood loss can cause the anemia. It can cause a hypovolemic shock in that thing. It's an emergency case. But the anemia for the blood loss basically is from the chronic blood loss. Like have some body condition with a bleeding disorder or something like that, and that can cause the anemia. And the second, and another cause is the produce of red blood cell is not enough for the body system, and can be like malnutrition, or the nutrition is not enough. That the nutrition that used for produce the red blood cell is not enough to produce that, or the hormone or the growth factor is not enough to release the red blood cell. And before you treat the anemia, you need to know what is the underlying cause that causes the anemia, and you can pick up all the selected agent and then to treat the anemia. And this is the picture from the bone marrow, from the stem cell and to the red blood cell to the system. And the stem cell is in the bone marrow. They need a signal. Most of them is a growth factor, hemopoietin, to signal for the stem cell to produce the red blood cell. And once the stem cell is produced, they're gonna have like a maturation of the red blood cell to the system. And from the maturation, as you can see, from the stem cell is a bigger size because they have the nucleus And once they become to mature one, the nuclear cell gonna be excreted from that. And red blood cell in the system is smaller than the stem cell. And if there's have something happen during the production, like at the beginning, you see the body system trying to trigger to produce more red blood cell, right? The once they produce, you're gonna have the more stem cell to the system. And that can cause megaloblastic anemia. Anemia. But if the production is not happen at all, like from the happen in the hematopoietin hormone, it's gonna cause like aplastic anemia. That means it's nothing at all. And for the something wrong and something happen at the end, especially for like during the maturation, they have the hypochromic anemia. For the goal of treatment, the anemia, as we know, we have to know the underlying cause first, and we can collect that, what we're gonna do. Like if that we want to stimulate to red blood cell more production of that, we need to use hematopoietic agents. But once anything happens during the maturation, they need a lot of nutrients to produce the cell, that we're going to use the hematinic agents to collect that problem. And regulator from the blood cell for the red blood cell is the erythropoietin, or we call EPO. But for certain cells, like from the white blood cell, like specific lymphocyte or the macrophage and stuff like that, we call colony stimulated factor, or we know as the CSF. Can be granulocyte cell or granulocyte or the macrophage. For CSF, we didn't use much in the veterinary medicine. They use a lot in human. For example, like the human, they undergoing for the chemotherapy and have leukopenia, and they want to increase the level of the leukocyte. They use the CSF, but in the veterinary, we didn't use that much. And another thing is the cost too, because the CSF, they need have like to produce in certain cell, and the cost is gonna be very expensive. For the nutrient, or we know as the hematinic, can be vitamin or the mineral. And we're gonna talk about 3 agents for the nutrient is the B12, folic, and iron. And for the protein, we didn't talk in the specific, but we're gonna mention the protein is in the plasma. Okay, the first one is the cobalamin, or we know as the vitamin B12. We call cobalamin because the chemical structure is a porphyrin structure and have the co-bond in center. And you can see the co-bond center. That's the name for the cobalamin. Cobalamin is a cofactor for the reaction to synthesis the purine and pyrimidine. And we know the purine and pyrimidine is the base for the RNA and DNA. So that is a key factor to help the cell to cell divide and cell maturation. So we can call vitamin B12 as a maturation factor. And you can see from the graph right here, right? This is the concentration of the thing we want to measure. The red line is referred to the hemoglobin, and the yellow line, yeah, you can see like very light color right here is the RNA, and they measure like the time or the age of the red blood cell. Like from the beginning, they didn't produce the hemoglobin for that time, but they use a lot of the RNA. So that means at the beginning for the maturation, they need a lot of vitamin B12. But almost the end, because the red blood cell going to become like the real red blood cell in the system, they're going to have a lot of hemoglobin in that accumulate in the red blood cell. Vitamin B12 deficiency is very rare, not because we can get easily, but because one we got from the nutrient from the food, we can storage the vitamin B12 in the liver for several months. That means for the condition have the vitamin B12 deficiency, it's not only from the malnutrition, it can be like any problem about the absorption in the GI, have like a chronic GI problem, and they don't have the absorbed vitamin B12 to the system. As I mentioned earlier, if you see like the picture from that, if they stop, because at the beginning during the stem cell, they need a lot of RNA and DNA to grow the cell, to mature the cell. And that they need a lot of vitamin B12. And one vitamin B12 is not enough for them, they're gonna stop like that. But they still continue to producing the stem cell, right? So that condition can cause the anemia, and that type of anemia we call macrocytic anemia. Because we can see like the red blood cell is bigger than the normal size, a megaloblastic anemia. In the human, they call pernicious anemia. You have a question? Yeah.
You said macrocytic anemia, is that the same thing as
megaloblastic anemia, and you will see the macrocytic red blood cell. Yeah, sorry. Yeah. This means the red blood cell is bigger than the normal size. For the disposition of vitamin B12 is pretty complicated, but it's not that, yeah, I will go to. Vitamin B12 is in the nutrient, is in the food that we intake. They need a little bit gastric acid to digest and become like a vitamin B12. I think I have an animation, yeah. Yeah, they come with the diet. But the gastric acid, it can destroy vitamin B12 too. So once they vitamin B12 in the stomach, they need something to protect that. And that they call intrinsic factor or R protein. Intrinsic factor and R protein, basically they produce from the parietal cell, from the stomach. But only that intrinsic factor is produced from the pancreas. And once vitamin B12 bind to intrinsic factor and R protein, they can protect from the gastric acid in the stomach. Yes.
So, like, say patients that have anemia of B12, right? If they were, let's say, on a long-term steroidal use, so they have an increased gastric acid production, but you need to try to protect it in addition to the R protein that's already protecting it?
Yes. We need to digest the protein and the diet in the food intake to release the vitamin B12. But once vitamin B12 is in the free form, it's easy to destroy from the acid. It's not just only for the gastric acid. It's in general, the acid can destroy the vitamin B12. But they need something like protein or the intrinsic factor with the vitamin B12 to protect them. And that from the stomach, they can carry to the ileum or the intestine, and that can then absorb that. Because they absorb in the ileum part, yeah.
Just for clarification, so
Okay.
intrinsic factor is for cats and then R protein is for everyone else.
Yes, for everyone else,
Okay.
yeah. Everyone have the intrinsic factor and R protein.
But cat specific.
All species, they produce from the parietal cell. The parietal cell we know is in the stomach, mucosa. But for only cat that have the intrinsic factor produced from the pancreas. The cat is all weird creature, by the way. You see anything exception for the cat, yeah. Yes, sir.
So that intrinsic factor, is that an exocrine or endocrine that's released from the pancreas?
Oh, that's a good question. It's not because the exocrine is a digestive juice, right, from that one. I don't know from the pancreas, but I was thinking it's just an autocot. It's not like a paracrine because they produce and they have the effect from the cell that's surrounding area. But I think for the cat, if we go for the definition, we can call the exocrine.
Okay, so then would stuff like EPI affect their ability to absorb or?
Yes, and they cannot digest the lipid, and they cannot produce for the intrinsic factor and cannot absorb for the vitamin B12 too. That's a good question, yeah. Yeah, I like you think about in the clinic because I like in the clinic related, yeah, thank you. Okay, and once they buy vitamin B12 by with this protein, and then gonna transfer all the travel to the large intestine in the ileal part, yeah. And at that ileal part, they're gonna absorb the vitamin B12 complex. And we know vitamin B12 is a water soluble, right? And it cannot like go to the passive diffusion like the other drug have the lipid soluble. So once they go to the cell, they have to have the special thing to go to the cell. They call that is pinocytosis. They need the receptor on the cell membrane, and receptor can gonna bind vitamin B complex, and vitamin B complex can absorb to the epithelial cell or enterocyte. And once they go to the enterocyte, they're gonna go to the blood system. And the blood system, they need a carrier to carry vitamin B12, and that carrier called transcobalamin. And go to the liver, and liver gonna store vitamin B12. That means in the blood system they have the carrier, and that's called transcobalamin. And transcobalamin is a complex of a vitamin B12 and can go to the liver and storage at that area. And once we have the vitamin B12, it's more than enough, that can excrete in the bile system. And the bile system gonna go to the GI again and reabsorb into the liver. And that's gonna go to the enterohepatic circulation. And that's why the vitamin B12 deficiency is very rare, because it can store it very long time, and once they excrete in the bile, and they can reabsorb again. Oh, I have an animation right here. There are 4 forms of the vitamin B12 together. First, methylcobalamin is the active form, but it's not commercially available because it's very easy to degrade it. And second one is cyanocobalamin, is semi-synthetic. The third, hydroxycobalamin, microbial synthesis. These two, cyanocobalamin, hydroxycobalamin, is available preparation. And the last one, adenosylcobalamin, is an unstable form. It's not available for use in the clinic. Yeah.
You said 2 and 3 were typically available in the clinic, and 1 and 4 are typically not.
Yes,
Okay.
yeah, that's correct. As we mentioned earlier, they have a complicated absorption in the GI tract. So most of preparation is in the is have like as a parental or viable form, which is have a cyanocobalamin and hydroxycobalamin is in the injection form. In the form you can giving as the intravascular or the intramuscular subcutaneous route. But for hydroxycobalamin, it have a protein binding and have a longer duration in the body system. Some preparation, but I haven't seen in the veterinarian form yet, is a nasal and buccal preparation, just a spray on that because they want to avoid the GI absorption. They want to absorb from the buccal mucosa cell. And you will see like a supplement in the grocery store, they sell as a vitamin B12 in the oral form. It can use that, but they have the limitation for the absorb. For example, the patient who has an anemia and vitamin B12 deficiency, as I mentioned earlier, is sometimes it happen problem in the GI tract. The absorption of the vitamin B12 is not very well. So if you use the oral form, it cannot be help that patient. Yes.
I'm sorry.
It's all right. No, don't say sorry. Yeah, it's all right.
May you repeat what you said about like the nasal buccal? They want to avoid what?
Avoid the GI absorption because we know the what you call the first pass effect, but this one is not the first pass effect. They want to avoid to absorb in the GI. They want to absorb